Okay, welcome video for Tuesday. We're going to talk about effective rate of interest or annual percentage yield. Okay, a lot of times car dealers will say your car loan, your APR is 3%. Well, remember, if you compound it monthly, like a monthly car payment, it ends up being actually more than 3%. Their effective rate or their actual yield is greater than maybe the 3% loan that they advertised, okay? Because of the compounding. We saw today that the more often you compound, the more interest is built up. The rate effective, R sub B, the effective rate is basically, remember, this is similar to the interest formula, 1 plus your rate over the number of times you're going to compute it, okay? All right? And that'd be for a year. And for this, we're just thinking about a yearly rate, the effective yearly rate, okay? So it's either quarterly 4, monthly 12, semi-annually 2, okay? So for a car payment, it would be 1, plus your rate, 3% would be 0.03 divided by 12 to the 12th power. And then you'll get like that decimal 1.002 something, and you subtract out that 1, and you get your decimal multiplied by 100 or move it back. Remember, when you go in 2%, you move it to the right, and you get your effective yield. So basically you take, very similar to the interest formula, I just don't have the K and the K times T, it's just the number of periods. We're just going to focus on a year, okay? So if this was, the effective rate would be, let's say for 3%, the actual annual percentage yield of the effective rate would be 1 plus 0.03 divided by 12. This would be for a 3% car payment loan, and again, this would be to the 12. Okay, this matches up. Okay, because we're just going to focus on here. And then we subtract 1, and we'll get our actual effective rate, or APY, okay? All right, so in this case, 2.5% quarterly, 1 plus 0.025 divided by n, or 4 times a year to the 4th power, minus 1. Notice the 1 plus 0.00625 to the 4th power gets me this. And when I subtract out the 1, notice I get a 0.02524, so I get a little extra there. So the car dealers get a little more than he says, okay, because of compounding, okay? So the percent is 2.524%, not 2.5% because of the compounding effect, okay? We'll figure out effective rates tomorrow in class. All right, an annuity. I always heard that my parents had an annuity. It's an insurance policy or like a retirement plan. An annuity is basically a sequence of equal periodic payments, okay? We're going to look at two things. One, how like maybe building up a retirement plan. We focus on interest on one lump principal, but now we're going to focus on how we figure out if we're putting in $500 every month and getting interest. Okay? So we got a present value and future value. Right now we're going to figure out, hey, what's our future value going to be if I'm putting in $500 a month at a certain interest rate for so many time periods? Okay? R stands for dollars, and this is 1 plus I. And I is interest rate adjusted for compounding period. Okay? That's basically the rate divided by K. Okay? Notice I is your interest per compounding period. So you take your rate. I should have put rate here, really. Let's try that. Or really rate per compounding period. So 6% a year, 0.06, and we adjust. I is where you've got all the adjusting. And if it's quarterly, 0.06 divided by 4, that's I. Okay. I is where you take your rate and you adjust it per compounding period. Okay. R is dollars, okay? So here's your formula again. Take your dollars here, R times 1 plus I, your adjusted rate to the N, how many times, okay, that you're going to put, how many you compute your interest, like monthly, okay? Okay, minus 1 over I again. Okay, so 1 plus I and all that to the n. Okay, so if you got 20 years and every month you put in money in this, and you've got your I adjust for monthly, you put in 20 times 12. 20 years of 12 months, okay? All right, let's take a look. $500 a month, 7.88% annual rate, compounded quarterly. What's your value in 20 years? My I is going to be 0.0788 divided by 4. Remember, I is your rate adjusted per compounding periodly, so quarterly. I get 0.0197. That's my quarterly rate. Here I plugged in the formula. $500. 1 plus I. Okay? And it's quarterly. How do I get 80? My n is how many periods, how many times I'm going to compute that, how many periods. Well, that was 20 years at 4 times a year, that's 80, okay? So 500 times 1 plus I to the n minus 1 over that, and I get, the value is going to be $95,000, okay, after 20 years for $500 a month at that interest rate, okay? Now, here's an interesting way. We're going to figure out, use a different formula, slightly different, where I'm not going to put in, we're not going to compute, before we were computing a future value after we put in $500 a month. Now, I'm going to start off with the present value, i.e. a loan, at a certain interest rate, and we're going to solve for R and figure out what your payment is. Okay, this formula is a little different. Now it's 1 minus, and in parentheses, 1 plus I, okay, your adjusted rate per compounding period, okay, to the negative n, okay, over I again. All right? So car payments are monthly, so it's going to be your rate divided by 12. So here's a case where I've got a truck that's $18,500. Okay? All right, truck is $18,500. You're going to put $2,000 down payment. Okay, so you're really going to take out $16,500. We need to figure out what this is going to be, but we know one, your rate is 2.9% annual percentage rate for a 4-year loan. So what's in? What's your total payments? It's going to be 4 times 12. Okay, your rate is going to be 0.029 divided by 12, right? We figure it out for the year, okay? So let's take a look. And this is what we'll do. This is $18,500 minus your $2,000 down. This is what your loan's going to be for. And in this area here, I can figure all this out. I'm not going to bother you with the math. We can just figure it out. I'll do 1 minus, in parentheses here, 1 plus, this is my I, the adjusted rate per compounding period, 0.029 divided by 12, okay? And it's to the n, and it's to the negative n. So that's quarterly, I'm sorry, not take that back, it's monthly, right? Monthly car payment, 12 times 4 years, that'll be negative, and it's to the negative n, that'll be a negative 48. Okay? So 1 minus 1 plus, and all this is in parentheses to the negative n, and then we divide it by I. This is I and this is I. So all that's divided by I. So all this will have a value, and we'll divide both sides by that value. And what you get is your car payment. That's how the formula, I'm sure the banks have in the computer, and you just plug it in based on your interest rate and so on. Okay? And that's how you figure out what your car payment is. Okay? Or any loan. I can make this a 30-year mortgage, and this would be maybe, what, $200,000, $150,000, and figure out what your mortgage payment's going to be. And that would be per month. This would be your rate divided by 12, but this would be what? 12 times, a lot of people have a 30-year mortgage, 360 up there, okay? 360 payments, okay? All right, that's all I have. That's what we'll be covering tomorrow, and then we'll move on Thursday, Friday to exponential growth and decay. All right. Have a good night.